We are going to work on some graphing today. So our target is going to be to model or graph exponential growth or decay, and we'll actually do a couple graphs that we would be considering neither. So just to remind you, what is a general form of an exponential function? Y equals ab to the x. And x has to be a real number, so nothing imaginary. A can't be 0, because if it was, there wouldn't be an equation. B has to be greater than 0, so this just means B is positive. And B can't be equal to 1, because if it was, we'd have 1, and the x value would change to different powers, but 1 to any power is going to stay 1. So that's why B can't be 1. Okay, a very important part of exponential models in general is that they're going to have an asymptote, and that's what we're going to see on the graphs here in a second. But an asymptote is a line that the graph approaches, but it's never going to touch it, and it's never going to go over it. We'll explain that in a second. And then the other thing we got to talk about real quick before we start our graphs is how do you tell if it's growth, decay, or neither? Okay, so if the A value is positive, then you have two things, all right? So if the A value is positive, you're going to have growth if the B value is greater than 1. Or if, again, the A value is positive, you'll have decay if B is between 0 and 1. Okay? If A is negative, which is, it's legal. You can have a negative A value. It will not represent growth or decay. If A is negative, you have what we call neither. All right, so it's still an exponential model, but it's neither growth or decay. So if A is positive, one of these two categories, growth or decay, and then that's based on the B value. If the A value is ever negative, which you'll see in a second, it doesn't fall into the category of exponential growth or exponential decay. So let's slide this up. Now, the first thing we're going to graph, y equals 2 to the x. I could maybe, you don't need to, but I could rewrite this as 1 times 2 to the x. So the A value there would really be 1, and the B value would be 2. So this guy is going to be growth, since our A value is positive and our B value is bigger than 1. Another important part of the equation is going to be the exponent. So if you're graphing something like this, and I'll show you how to do this on the calculator as well, but if you're graphing, it's always a good idea to make yourself a table, which I have provided here. Now, what I would tell you to do, whatever sets that exponent equal to 0, whatever sets that equal to 0, put that in the middle of your table. So I'm going to graph 5 points. So to set x equal to 0, I would just plug in 0. So I'm going to put that in the middle of my table. And then I'm going to do a couple numbers that are bigger and a couple numbers that are smaller. So this is always a really good table anytime you want to get a general idea of a graph. If you're not sure about, plug in those 5 points, 0, 1, 2, and then -1, -2. Okay, now we're going to do 2 to the x. So, of course, you can grab your calculator. So, like 2 squared is 4, 2 to the first is 2, anything to the 0 power is 1. What I want to make a reminder for you guys with are these negatives. So, remember, negative exponent is not a negative number, so 2 to the -1 is 1 over 2 to the first, or 1/2. So this would just be 1/2. 2 to the -2 is going to be 1 over 2 squared, or 1/4. Okay, now I'm going to grab a highlighter real quick. What I want you guys to do here, we'll talk about the asymptote, that's why I want to grab my highlighter in a second. If I kept going with the table the other direction, like if we did -3, we would have 1/8. If we did -4, we'd have 1/16. And these fractions would continue to get smaller, 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 but they would never be negative, okay? And so the graph is going to get really close to the asymptote, which for this question it's just going to be the x-axis, which has the equation y equals 0. It's a nice horizontal line. So my asymptote here is going to be y equals 0. We're going to get really close to this, but never touch it. Basically what happens as you continue to put negative x values into the table, you'd get smaller fractions, but you would never actually get to 0. You would never actually go negative. Now, as you guys are trying to plot these points, like the 2, 4, you could plot that in your sleep. That's not bad. 1, 2, that's not bad. 0, 1, those are not bad. Any of these that have fractions, just do your best to estimate. So, negative 1's at 1/2, negative 2's at 1/4. I added that 1/8. Give you a general idea of the shape. Now, if I did plug in 3, let me just add that in here. 3, 2 to the 3rd power would be 8, to give you another point here to see the shape a little bit better. So these exponential growth models, they get bigger very quickly, and it's kind of this like J shape almost. And so exponential growth is going to get larger as your x values get larger, so it's going to kind of go up from left to right, but there's no slope and no specific pattern we can follow like a quadratic, so I'm just plotting specific points. Okay, domain for any of these, and it doesn't matter how, if it's a growth, decay, neither any of these. This is going to go to the left forever. This is going up really fast, but it's going to the right forever. So the domain is going to cover the entire x-axis, so negative infinity to infinity, all real numbers. The other part that's tricky here, a little different than what you guys are used to, the range. Okay, so the range is going to have a connection with the asymptote. Now remember, I told you if we kept this table going and we did like -5, -6, this would keep getting closer and closer to the x-axis, but it would never touch it and never go over it. And then all the rest of the graph is above here. So when we do the range, because you don't actually touch 0, we're not going to use a bracket, we're going to use a parenthesis in our interval notation. So whatever your asymptote is, asymptote right there, is going to be involved in your range. So everything is above that asymptote, so the rest of the graph goes up forever, goes up to infinity. Okay, so this one is growth. Now, here in my next example, a value is 36, b value is 1/2. So this is positive, this is between 0 and 1. So this is going to be a model for you. What does exponential decay look like? Again, in the middle of my table, I want to put whatever would set that equal to 0. So I'm just going to do 0. It's very similar to the last table. We'll just do 1, 2, and then we'll do -1, -2. Okay, now when we plug these in, this is going to be 36 times 1/2. Oh, I'm sorry. Yes, 1/2 squared. All right, so this would be 36. If I squared that, I'd get 1/4. And so 36 times 1/4 would be 9. If I did here 36 times 1/2 squared, that's going to give me, I'm sorry, 1/2 to the first. 36 times 1/2 is 18. And 36 times 1/2 to the 0. Anything to the 0 power is 1, so this is just going to be 36. Now, the negatives here are probably going to throw you off a little bit. And I wish I had given myself a little more space on here, but let me write this up here. So if I do 36 times 1/2 to the -1, if you guys remember those negative exponents, this would be 1 to the -1, 2 to the -1. These would actually trade places, so I would turn that 1 to the -1/2 power would actually be 2. So I'm actually taking 36 and multiplying it by 2. So that's why that number is going to be a much larger. If I do 36 times 1/2 to the -2 power, which we would do next, this would be 36 times 1 to the -2 over 2 to the -2. If those switch, we'd have 2 squared over 1 squared, which would end up being 36 times 4. So that's why that number is going to get larger. That'll give you 144. Okay, so again, these graphs, we're just going to kind of do our best to estimate. Whatever would make that exponent 0, that's going to be involved with making the table. In this case, your asymptote here is actually going to be the same as it was on the last question. And let me go ahead and try to graph this best I can. So just kind of estimate, this goes by tens it looks like, so I'm going to put the 144 kind of like right in there. Negative 172, just kind of estimating. 036, maybe kind of in there. 118, 29. If you did another here, you can see each one of these is getting cut in half. This would be 4.5. And it's going to be this shape, but it's going to be flipped over. So I didn't do a good job drawing that arrow there. So just kind of gets really close. And again, I'm going to, as I continue to go here, these numbers will get smaller, 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 but there'll be smaller and smaller fractions. They're not going to touch the zero. They're not going to go negative. Your asymptote here again is going to be the x-axis, which has the equation y equals 0. Domain, this goes left forever, this goes right forever, so you're going to cover the whole x-axis. And then the range actually is the same, even though it's flipped over going a different direction. You're not actually going to touch the 0, so we're going to use a parenthesis, and then everything else is above that, so it's going to go up to infinity. All right. Now, both of these exponentials down at the bottom, I've got y equals negative 2 to the 1/2, negative 2 times 1/2 to the x, and negative 3 times 2 to the x. Both of these are going to be in the neither category because that a value is negative. So we're not doing growth or decay, but we still have an exponential model here. What's going to happen? That negative is just going to take like a normal, this would be decay if this was positive. It's going to take kind of the graph we did above and just flip it down. Same thing here, the negative 3, this would take like a growth model and just flip it down. Now, what I want to show you here, again, I'm going to have us make a table, and whatever would set that equal to 0, I'm going to put in the middle. So all these on the front, I'm just going to use that negative 2, negative 1, 0, 1, 2. What I want to show you on these two graphs is maybe a way to speed the process up a little bit by using your graphing calculator. So I'm just going to grab my graphing calculator here. Now, I'm going to go into the y equals button, and I'm going to type the equation that I see. So make sure you use the negative key under the 3. Don't use the subtraction sign. So I'm going to do negative 2 times 1/2. And then for your exponent, we got to use the caret button here. So that's right above the division key. So there's the caret. And then remember, for x, you have to use this button here next to the alpha key, the x, t, theta, n. That gives you your variable. So I just hit y equals, and I'm typing in my equation. Now, I'm not actually going to look at the graph. I'm going to use this to get to my table. So I'm just going to hit second and then graph. Just second, graph, and you'll see the second function there is the table. And so this is just a little faster way than plugging everything in by hand, but you can scroll up and down here. We decided to do the negative 2, negative 1, 0, 1, 2. So I'm just going to grab those points from the table, literally right there. Oops, I just messed that up. Oops, this is at negative 1, sorry guys, negative 1/2. And then you guys can see these continue to get smaller, smaller, smaller as we go. Now, 5 points should be a good idea to get a general shape, so I'm going to pause and graph these points. I got my graph going there. Now, the asymptote is still the x-axis. In this case, we're going to get really close as we continue here, but we're never going to touch it, never going to go over it. So y equals 0, nice horizontal line where all the y coordinates are 0. The domain, I know this is going down, but this is still going left and this is still going right, so still negative infinity to infinity. The range is what's going to be different here, but still related to the asymptote. Now, remember we approach from the bottom because when you write your interval notation, you want to start with the lowest. This points down, so it does go to negative infinity, and then it's bounded by the asymptote. So it's going to stop at the asymptote. So we're not going to quite reach 0 because we're just going to get infinitely closer to that. but we're not going to touch it, not going to go over it, so we don't have a bracket, we have a parenthesis. And then I'm going to slide over, and you guys will see this will be a flipped over version of a similar graph to part A. This is a flipped over version of a similar graph to part B. So this is going to be, if this was positive, this would be growth, so it's going to take that model and flip it over. So I'm just going to go through real quick again how to do this on the calculator. And let me show you a quick trick. Let's say you're in the table and you don't want to be in the table anymore. If you ever want to go back to the main screen, just hit second, and then the button right next to it, the second function is quit. So if you're ever in a screen you don't want to be in, just hit second, the mode button right there, and that'll take you back to the main screen. I want to go to the y equals screen, so let me lay this over here, and I'm just going to clear this out. So we're doing -3 times 2 to the x here. And of course, if you don't have a graphing calculator, you can plug these in by hand and do that. Once you type your equation, second graph takes you to the table. And I'm just going to copy down what I have. So -2, I'm at -0.75, -1, we're at -1.5, -3, -6, -12, and I'm going to pause and graph. All right, and so you guys can see this negative takes what would have been an exponential growth model and flips it down. Asymptote on all these on the front is going to be y equals 0. We'll talk about that more on the back. This still goes left and right forever. And even though it's kind of different direction than this, the range is actually the same. It's going to go down to -infinity here, and it's going to be bounded by that asymptote, but we're not actually going to touch it or go over it, so we have a parenthesis instead of a bracket. Now, on the back here, we are going to shift some exponential functions. So I'm going to write AB to the x would be your general form. If you're going to shift, you're still going to have a and b, but you might see some other things. So your exponent, I'm going to write x minus h, and then to the side, I'm going to write k. Now, this works the same as it does for radicals, quadratics, what else have we shifted? Absolute value. So what's going on here in the exponent? This is going to go the opposite way that it looks, and then it's going to shift the graph left or right. Outside, not part of the operation with the exponent, if I have this k, this is going to copy whatever that is, and that's going to shift the graph up or down. And the other thing I'm going to write down here, that number, that k value, is going to affect your asymptote. So whatever that k value is will be the asymptote. I didn't have any k values on the front, and so our asymptote was just y equals 0. So here, if we have a k value, which we'll see this in a second, that's going to affect your asymptote, and that's actually going to affect how I would tell you guys to do the table. Okay, so we're going to actually describe the transformations of these. All right, so because the x is by itself, if I just had y equals 3 times 2 to the x, that's what we're going to describe the description, or describe the change from, or the transformation. This is not going to move left or right because this is just an x by itself. So if I was to describe this, this is going to go up 5 units from y equals 3 times 2 to the x. That's all that's going to go on there. When I make my table here, I'm just going to do my x and y again. And what would set that exponent equal to 0 would be 0. So I would set that in the middle, just do 1 and 2, -1, -2. Now, this guy should be exponential growth because I have a positive a value, and then my b value, the 2, is bigger than 1. And what's going to happen here is my asymptote, let me see if I can slide this and get that on the screen. Okay, so the asymptote there is just going to be whatever that is. So this is y equals 5. So I'm just going to come to my graph right this second, and I'm going to plug in. This basically is shifting our x-axis up, and the shape of this is going to be that J shape. It's going to get really close, but it's never going to touch and never going to go over the 5. Okay, so let me just grab my calculator to speed this up a little bit. I'm going to type in, I'm going to delete that actually, and we can just use this from the last problem. and then just put the plus 5, make sure it's to the side there, and then I'm just going to hit second table, and I started it at -2, so 5.75, and you guys can see in the table here how these are getting closer to the 5 but not touching it, not going over it. Where were we? Okay, so 6.5, 8, 11, 17, and I'm going to pause and graph. So I got the graph on the screen there. Now, domain for every single one of these, even though I've shifted this up 5 units, we're still going left and right forever. So the domain covers your whole x-axis from -infinity to infinity. Your range, again, is affected by the asymptote. So now here, if I approach this from the bottom, I don't touch anything till I get right over that asymptote. So remember, we don't touch the asymptote, so a parenthesis at that 5, and then that goes up forever to infinity. All right, now my next equation here, my next exponential, very similar. Whatever would set that equal to 0, which would be -1, that's what you want to put in the table. And that kind of goes along with our opposite copy. So it's the opposite of what that looks like. Now, what this is going to do as far as a description, if this is x plus 1, this is going to actually shift the graph left 1 unit. That -1, that's my description there. It's going to take the y equals 3 times 2 to the x and shift it left 1 unit. Now this is important. Whatever this is goes in the middle of the table. So instead of 0 in the middle, I'm going to put -1. So two larger numbers would be 0 and 1. Two smaller numbers would be -2, -3. This will just give you a better idea on your table. So once I've got that, again, if you're in a screen you don't want to be in, just second the mode button, I just call it second quit in my head, or you could just click the y equals. Now I'm going to clear this out real quick. I'm doing 3 times 2 to the x. Now this is important. If you have a calculator like I have right here, you can just type x plus 1 and you can see that is in the exponent. If you cannot see your exponent, if you have a caret button that appears when you do this, just do me a favor, and you can do this with the same calculator here. Just put parentheses around your exponent if you cannot see your exponent. Okay, if you see the caret symbol, you need to put parentheses around that exponent or it won't work. And if you have this calculator, you might just do it just to get in the habit. Okay, so this, then the x plus 1, that whole thing is my exponent like it is in the equation. Once I got that, just hit second table, or sorry, second graph, and that gives you the table. And you can scroll this up and down. So -3, we got 0.75, 1.5, 3, 6, and 12. And I'm going to pause and graph. Actually, before I pause and graph, I don't have anything added or subtracted. So my asymptote here, this would be like a +0 on the outside if you want to think of it that way. So your asymptote is going to be the x-axis like it was for the questions on the front. So it's going to be the y equals 0. Now I'm going to pause and graph. And you'll see this should be exponential growth here. Sorry, I should have written that down. We'll do decay in the next step. But we're kind of that J shape. From left to right, we're going up. Your asymptote here, because we're not adding or subtracting, y equals 0. Domain for every single one of these is going to go left and right forever. The range here, you don't start touching any part of that graph till you get just above the asymptote. So again, don't use a bracket. That asymptote is 0, and it's going up forever, so it would go and cover all the y values up to infinity. All right, now we're going to describe these two. This is 4 times 1/2 to the x would be like our parent function or our general function here. So this is going to go the opposite way that you think. That's going to go shifting the graph left or right with that exponent. Whatever's with the x does the operation left or right. So this is going to go right 2 units for my description. And anything outside we're going to copy. So that would be the -3 or down 3 units. So if I'm doing my description, this is going to take 4 times 1/2 to the x. We're going to go right 2 down 3 is what the shift would be. Now, in terms of making the table is going to be affected by the exponent only, not the asymptote. So, or not this added or subtracted. That's the asymptote. This is the table. So, whatever would set this equal to 0, which would be 2, I'm going to put that in the middle of my table. And then just do 2 bigger numbers, 2 smaller numbers. That should give you a good idea of the graph. Whatever's added or subtracted here, that's going to be your asymptote. So I'm going to write my nice horizontal line at y equals 3. Oh, fail, 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 fail. Forget I just did that. Pretend I did -3. Don't look at that. Crud. -3 down here. It's -3, so y equals -3. That's your asymptote, my fault. Okay, now I'm going to grab my graph. And again, I would just second quit, or you can hit y equals. I'm going to clear this out. So 4 times 1/2. Okay, for my exponent, I'm going to just put parentheses just to be safe. My whole exponent is x minus 2. And then I'm just going to use the arrow key to get down on the level with the rest of the equation and write the -3. So I'm typing that in. Second table. And we're starting this one at 0 so we can get a good idea, but you guys can see these numbers go up, up, up as you put in more numbers that are negative here. So I'm going to pause, write this down, and graph. Alright, so forgive my mess up with the asymptote there. This is your graph. This kind of, in this case, since it would be decay, it's like a backwards J shape. This is decay because the A value is positive and the B value is between 0 and 1. Should have written that down. Domain, all of these -infinity to infinity. Now, your range here, I start touching part of the graph right when I hop over that asymptote at -3. So my range, parenthesis at -3, and then it's going to go up forever, so infinity. And one more graph we're going to do here really quickly. This has 2 things going on. So if I'm just thinking of the graph of y equals 4 times 1/2 to the x, that negative, what that's going to do is be a reflection over the x-axis. So that's going to take the graph and flip it down. And that exponent, opposite of what that looks like, that would be a -3. This is going to shift 3 units left. And so that's also going to affect my table. I don't have anything added or subtracted, so our asymptote is going to be y equals 0. But I am going to put whatever would set that exponent to 0 in the middle of the table. So -3, 2 bigger numbers, 2 smaller numbers. That'll give you a good idea. You don't have anything added or subtracted, so your asymptote is going to be y equals 0. I'm just going to highlight that. And I'm going to type this in. So I'm going to go y equals, I'll just clear that out, 4 times 1/2. You guys could also type in the 0.5 if you want to do that instead of writing out the 1/2. Now, my whole exponent is x plus 3, so I'm just going to put parentheses around that to be safe. And then once I've got that typed in, just hit second graph. That'll take you to the table. Now, -5 is at 16. This is 8, 4, 2, 1. You can see if you want to extend the table a little bit, 0 is at 1/2, and then you keep getting smaller. So, oh my gosh, guys. Forgive, I forgot the negative. Shoot, I'm going to get a negative in here. No. Insert a negative. There we go. Okay. Fail. Let me go back to this. So these are just going to change these guys to be a negative. That's all that's going to happen there. So just change into negatives. My fault. So to do that, I did second, and then I hit the delete key to insert the negative sign if you haven't seen that before. And my apologies. So my table is correct, except I needed to put negatives. And then I'm going to pause and graph. But let me do that first one. So -5, my graph only goes down to -15 here. So I'm just going to kind of extend this a little bit. It would go 1 further down. So that's fine if it doesn't exactly touch the graph. -4, -8, -3, -4. And I'm just graphing this with you guys now, I guess. -1, -1, 0's at -1/2. Okay, so this has got that J shape. It's flipped over. It's going to get real close to that, never touch it, never go over it. Domain for every single one of these, doesn't matter which direction it flips, is going left and right forever, so negative infinity to infinity, whole interval. Now here, the range. This is pointed down, so the lowest value would go to negative infinity, and then it's bounded by the asymptote here is going to stop, so you're not going to touch anything above that asymptote, which is at 0, so it'd be negative infinity, comma 0. Again, a parenthesis, not a bracket, because you get really close to an asymptote, but you never touch it, never go over it.